Hello everyone, myself Shalini. I am from the Department of CSC, working as Assistant Professor at Marri Laxman Reddy Institute of Technology and Management. Today I would like to share a few concepts about the basics of programming, especially whenever we are learning some programming languages like C or C++, we would learn how to implement them, the basic concepts and all, from where all the programming paradigms have started, and how do we develop, what is algorithm, what is flowchart, will be covered in these sessions. So the first concept is programming paradigms. So here we are going to learn how the program is going to start. So first of all, we do programming for the purpose of solving any particular task or performing any functionality. We write a program. So here we are having two types of programming paradigms. One is imperative, another one is declarative. So what is imperative and declarative? We'll see the definition of that. So imperative will go with sequence of commands. So whatever task we would like to implement, we will go with the commands given in the form of instructions in the program. So your program will run according to the instructions, and the state of the program changes according to the instructions, and the output will be shown on the screen. So next type of is declarative. In declarative, we are going to specify the instructions, but mainly we don't concentrate on how the instructions have been specified or how the problem is going to be solved. Rather, we are mainly focused on what would be the result. So how the result is going to be, what would be the result, but not how it is going to implement that or how it is going to give the instructions on that is not concerned in declarative programming. So for example, if you take the first one, that is procedural programming. For example, if you want to print numbers from 1 to 10 using C or C++ or Java programming language, we need to write a code where our initial process should start, the count process should start from 1, and 1 should be printed. Next it should be incremented to 2. So the next number should be printed, 3, and so on up till 10, and all the numbers should be printed on the screen. So here we are more concerned about how the instructions have been written and how the sequence is written and how the state has been updated every time. So C or C++ or Java comes under this type of programming paradigms. Coming to declarative programming paradigm. So here, for example, if you want to implement the same problem, that is to display the numbers from 1 to 10. For example, if you take the programming language like Python, here we are not going to declare, we need not consider any initial state. So we can just give a single line, so where we can tell that you want to print the numbers from 1 to 10. Here you are not going to update any state, and you are not concerned with how that is going to run, how the sequence of commands are going to run. Rather, we are concentrated only on what is the output there. So this is declarative paradigm. These are the two types. So here you can see the examples. Under imperative, you are having two types. One is procedure oriented and object oriented, and under declarative you can see functional and logical. So under procedure oriented, so we are having programming languages like C, C++. Under object oriented programming, you are having C++, Java. So C++ can be called as a hybrid language where it includes the concept of C as well as object oriented features. So let us go into the differences between this procedural and object oriented programmings. So coming to procedural programming language and object oriented programming language. So here in procedure oriented language, mainly the program is divided into functions. Whatever task you want to perform, that complex task will be divided into simple modules. For example, you want to implement you would like to implement a complex task, like you are conducting a fest or an annual day in your college. So here all the things will not be carried out by a single person. So if you consider the activities whatever you want to perform on that particular day, you can divide into some parts. So one is the cultural events, and another one is academic events, and cultural events can be further divided into some dance or singing, and academic events can be divided into some PPT presentations or anything. So here you can see how a complex task is being divided into simple module. Similarly, the procedural oriented programming also implements this type of modular programming. It divides any complex task into simple tasks, that is in the form of functions. So this type of programming languages are mainly based on functions. Each task, whatever you want to perform, can be implemented in the form of a function. So that is about procedural. And coming to object oriented programming, here the concentration is mainly on classes and objects. So here, rather than depending on functions, here we need to create some objects of some type class. For example, if you consider a class of some CSC. So what does a class contain? What will be the features of the class? So a class may contain some students, and the students may have some roll numbers, and they may have some names related to some their mid marks or total marks or whatever it may be. So all these are the features of a particular class called as CSC. Now here the class CSC, we have told what are the features of CSC, but physically you can't show the existence of the class. So what you can show here is you can show an object that is a student of class CSC. So object will have the physical existence. Object is a type of class. So here we are mainly concentrating on what are all the features we want to be implemented. So that features we consider in a class, and whenever you want to implement a class is a virtual thing. So here we take object into consideration. An object is of type class. So object oriented programming is mainly based on this type of programming, that is class and objects. And next, in procedural, the main emphasis is on doing things. So how you divide the task into simple modules, and how do you further divide them into submodules. So how you are going to write a program for that particular task or function is our main concentration on procedural oriented programming. And here in object oriented programming, how the data is being analyzed and how are you going to create objects for that, how a class has been defined is the main thing. And next, what is the problem with procedural oriented program is poor modeling to real world problems. So coming to real world problems, for example, you take the programming language like C. C is used for developing operating systems or compilers, and it is mainly related to system programming. But when it comes to real-time problems, like you want to develop an application, a real-time application or a mobile application, whatever it may be, so C may not be useful for all different types of applications, because an application contains or it needs many things to be involved, like security or integration, data integration, or many things. So procedural oriented programming is far away from these concepts. That is the reason for things like the applications, whatever you want to implement in real time, we are going towards object oriented programming. And next one, it is not easy to maintain project if it is so complex. So complexity in the sense, so what I told just now, that is when the data is very large or you need to provide security, the complexity of any particular project or a complex problem, whatever it may be, it is not that easy in procedural oriented programming compared to object oriented programming. It has many secured features. So when we are implementing these type of problems, we go for object oriented programming. So the same thing, that it provides poor data security, and object oriented programming provides a strong data security. And next, the next points are, it is not an extensible programming language, but coming to object oriented program, it is highly extensible. So the productivity, that is what are all the things that you can, or what are the applications you can develop from these languages, it is very low compared to object oriented programming language, where you have high feasibility of developing different applications. And next here, it do not support some new data types, because whatever old data types we are having, like integer, float, and apart from of this few data types, it doesn't support more. But coming to object oriented data type, so we can have some feasibility to include more number of data types. Here the main concept is function, and in object oriented programming the main concept is class. So here the examples are given that under procedural oriented programming you're having Pascal, C, Basic and Fortran. So these are different programming languages. So initially we have some programming languages like COBOL, Fortran, Basic and all. So these programming languages are mainly designed for some specific needs. For example, COBOL is designed for business purpose, business oriented calculations or data maintenance and all. And coming to Fortran, it is used for some scientific calculations and all. So basically they are designed for that purpose only, and whatever problems you are solving from one programming language cannot be implemented in another programming language. So later, apart from that, a new programming language C was developed, which has been commonly used for solving different types of problems compared to the previous languages. So this is some process of hereditary, how the C language has come into existence, and later C has given rise to, or it has influenced many languages like C++ or Java or Python or anything. So even though many languages are there, we start our academic process from C language because it provides a basis for all the remaining languages. Once you understand the concept present in C language, you will be very feasible, and it is easy to understand how different languages have been implementing different concepts. So what are all the programming languages that have been developed after C? They are not completely new. So they have taken few things from C and added some additional concepts to overcome the disadvantages of C programming language. So we'll go to the next concept, that is algorithm. So before starting a program or before writing a program, there is an important thing, that how to start the process of writing a program. So for example, if you're having a task, how to deal with the task, we write some process or we write some analysis, and according to that step by step procedure we implement that particular task. For example, if you want to go from your home to the college, what is the process involved there? So first, after coming out home, so where you should stay, at bus stop or somewhere, or take your vehicle, and how much distance you need to travel, and then after that, after going to your college, you need to park it, and next you need to go to your class and attend the sessions and labs and all. So what you can see here, in order to reach your destination or in order to perform any particular task, we need some steps to be involved there. It is not a direct process, we get the direct output. So this is what we call algorithm in the concept of programming. Whenever you want to write a program for any particular task, so we first write an algorithm so that a program can be developed very easily. Because for example, if I say that I want to add two numbers, so orally you can add two numbers, you can take two numbers and you can add. But when you are implementing using a program, it is not a direct calculation. We need to tell how many variables are involved in that, how many inputs you are taking, and what is the formula to calculate addition, and where the output is stored, and how the output is being displayed. So all these things have been involved in writing a program. So it is always advisable to write an algorithm before you write any program so that you don't miss anything in the program. So we'll go for algorithm, the definition of algorithm. So algorithm is a step-by-step method of solving any particular problem. So here, by using algorithm, you can solve a problem or you can make a decision. So here, whenever you are solving a problem, generally you can divide a problem into two types. One is problem solving and decision making. For example, if I want to calculate simple interest, so I need to implement the formula simple interest equal to principal amount into time into rate of interest by 100. So whenever I have the values of this principal amount, time and rate of interest, so I get the value of simple interest. That is what I get. So here you can say this type of problems comes under problem solving. So what are the inputs I need here is, I need the principal amount, I need the time, and I need the rate of interest, then only I can get the value of SI. So coming to another type of problem, for example, I want to check whether a number is prime or not. So when you can decide a number is prime number, a number if it has only two factors, that is 1 and itself, you can call that particular number as prime number. So here it is not a problem solving directly, it is a decision making algorithm. For example, if I am having a numbers between 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now if I want to decide what are prime numbers, I need to start the process from first number 1. It is not a prime number. Coming to the next number 2. So 2 is having only two factors. What are the factors of 2? That is number 1 and itself, that is 2. Coming to 3, this is also a prime number because it has only two factors, 1 and itself, that is 3. 4 is not a prime number because it is having three factors, that is 1, 2 and 4. So next 5 is a prime number because it is having only two factors, 1 and 5. Similarly, you will apply for other numbers also. And finally, you are going to decide that the prime numbers are 2, 3, 5 and 7. So here decision making is a most important thing. You are going to decide which is a prime number and which is not a prime number. So for even solving these type of problems like calculating simple interest or for decision making problems also, you can implement the concept of algorithms. But how do we implement algorithms, or what are the rules we need to follow? So those are nothing but the properties of algorithm. So we'll see in the next slide what are the properties of algorithm so that you can write algorithms in an efficient way. So coming to next one, properties of algorithm. The first property of any algorithm is finiteness. Finiteness. So the name itself is telling it is countable. So an algorithm should be terminated after finite number of steps. So what does it mean? An algorithm, after you write, after few points or after few steps, it should be completed. So it should not go on to infinity. It should be completed or it should be terminated after or in a finite number of steps. So that is the first point. So whenever we write an algorithm, you should have some starting point and ending point. It is not that you keep on writing, because if you keep on writing, there is no end to how to solve the problem. So that is the first point or the first property of algorithm. Coming to next one, that is definiteness. So definiteness in the sense, whatever instruction you are writing in the algorithm should be very clear and there should not be any ambiguity. Ambiguity is confusion. So whatever instruction you are writing, it should not lead to any confusion. For example, you are guiding a person to go from some source A to destination B. So whatever you are guiding to that particular person, he should be able to reach destination B without any confusion. It should not lead to any other route like C. That means whatever instruction you have given, that instruction contains the property of definiteness. It is not leading to any confusion. Similarly, when you write an algorithm, it should not lead to any confusion, because what is the next step after writing the algorithm is we should implement program. If your algorithm is led to confusion, then it is difficult to obtain output in the program also. So that is the next property. And coming to the next one, input. So how many inputs you can give to the algorithm is, an algorithm can accept 0 input. Without any input also, it can provide some output. For example, if I want to display my name, then in a simple program, I can just write a statement called as printf, which we'll see these concepts later, but I'm giving an idea what you need to do. So printf is nothing but whatever you want to print on the screen. So you are giving printf, you write in printf, it will be displayed as it is. If you consider this particular problem, whatever instruction you are writing inside printf, the same thing will be displayed on the screen. And your compiler does not ask you, or your computer doesn't ask you to give some input for that, because it is already provided. That is, with 0 input also, it is able to provide some output to the user. For example, you take one more example, that is addition of two numbers. If I want to perform addition of two numbers, so what I need to do here is, when I want to add two numbers, I need two inputs here. Let it be 5 and 3. So when I have two inputs only, I can perform addition and I can give the answer as 8. So what you observe here is, how many inputs are provided in this problem is two inputs 5 and 3. So you are getting output 8. in the above problem, no input is provided, just I have written in the statement and the same thing is displayed on the screen. So to display output or to provide output to the user, your compiler does not require any input. That is the reason we say an algorithm accepts 0 or more number of inputs. You can give 2 inputs or 3 inputs or 10 inputs, and you can give 0 inputs also to get some output. That is another property of algorithm. And coming to next one, output. So how many outputs an algorithm produces? An algorithm produces at least one output. We should remember that the main aim of a programmer is to provide some output. That is the reason we write a program. Without getting an output, we are not interested in writing a program. We give some instructions to the computer in the form of a program because we are expecting some output. So how many outputs will be provided? Minimum one output should be produced. An algorithm should be written in such a way or designed in such a way that it produces at least one output. Okay, for example, if you are considering the above problem of displaying your name, what is the output? Your name is the output. You got your name as output. And for example, if you take addition of two numbers, what is the output you are getting here? You are getting the number 8 as output, one output. And if you take the previous problem, that is prime numbers from 1 to n, how many outputs you got here? 2, 3, 5, 7 are outputs for us. So an algorithm is capable of producing at least one output. And coming to the next property, effectiveness. So what is the meaning of effectiveness is your instructions that have been designed in the algorithm should be very basic and reliable. It should be easy to understand to write a program, because the main purpose of writing algorithm is to make the programmer feel easy to write the program. So again, you should not have complex instructions in the algorithm. Your instructions in the algorithm should lead the programmer feel easy to write the program. So these are all the things we should consider whenever we develop the algorithm. And we need to remember here, algorithm is not an executed part. Algorithm will be written by the person or the programmer. So how you are going to write the algorithm is your own style or your own way, following some basic things in the algorithm. It is not like you should exactly write in the same way, but we follow some basic rules to write the algorithm. So we'll see some examples how to write the algorithm. So this is the first example how to write an algorithm, that is addition of two numbers. So here we represent with a start because to indicate that you are going to start the process of algorithm, and last one is stop. As I told you, algorithm is not an executable thing. You can't execute this algorithm and get some output. Algorithm is providing you a way to how to write the program. Now by seeing this algorithm, I can design a step-by-step program so that I can perform addition of two numbers. So coming to this addition of two numbers, now see, the first step is start, that you are going to start the process, and next you are declaring two variables, number 1, number 2, and these two are called as input variables for us. These two are going to handle inputs, and one more variable is declared, that is sum. So this is an output variable which will handle your output. So here the total number of variables required for this particular problem is 3 variables, 2 are inputs and 1 is output. So what is the next step? Read the values. The meaning of read means taking the input. You have to take inputs into these two values. So what are the values I am having here? One is number 1, another one is number 2. I will take two values. Let it be 10 and 20. So now after reading the two values, what is the next step? Add number 1 and number 2. So you will get some answer and assign the result to which variable here? Sum, because sum is a variable which is holding the output. So in number 1 I am having 10, in number 2 I am having 20, number 1 plus number 2, 10 plus 20, I will get the answer 30, and that 30 is given to which variable? That is sum. So the same thing is happened here. 10 plus 20 is added and you are getting the answer as 30, and sum will be displayed on the screen. So that's it. Your task is completed, and next you can go for stop. So what is the process that is being involved here is you are going to start the process. First you need to Verify how many variables are required to solve your problem. Because this is addition of two numbers, the question itself is telling you require two inputs and one more variable for output. So totally you require three variables. And next, for two inputs, you need to take two values stored in the two variables, number 1 and number 2. And then you need to tell the formula how to add also. Don't think just computer will add. So you need to specify everything very clearly, what operation you want to perform. Whether it may be arithmetic operation or any other operation, you should specify each and everything in your program. That is the reason in algorithm also we specify all these things. So you are giving the formula how to add two numbers, that when you add number 1 value plus number 2 value, the answer is stored in the variable called as sum. Now the answer is present in sum. We want only the answer to be displayed on the screen. So you are using the word display. Display means the output which you want to see on the screen. So two important words we need to remember here. One is read, another one is display. Reading involves in taking input from the user. That is, your program requires those values to implement that particular task. And similarly, display is after the task is completed. The answer or output is stored in a variable. That is what you want to display. For that reason, you can use the word called as display. So after the task is completed, we will write stop. So how many variables you are going to declare totally depends upon the problem. Suppose if your problem is to calculate simple interest. So as we have seen previously, what is the formula for simple interest? SI equal to P into T into R divided by 100. So here P is principal amount, T is the time and R is the rate of interest, where 100 is a constant value. So how many variables you require? Totally I require 4 variables, in which 3 variables P, T, R are input variables and SI is the output variable. So it changes from problem to problem, how many input variables you require and how many output variables you require, which comprises of the total variables you require for that problem. So now you can see this type of algorithm is a problem solving. We are solving a problem. We are not taking any decision here. We are having some inputs. We know the formula. We are implementing it and we are expecting the output for that. Now let us go for the second type of example, that is to check whether a number is even or odd. So this is not a problem solving. Here we need a decision to be taken. Our output is not a direct problem solving. Our output involves a decision making. Maybe initially we will solve a problem, but our final output is mainly based on decision making. Now the problem here is to check whether a number is even or odd. So as we know the general logic, what is a number, which number is even number and which number is odd number. So when you decide a particular number is even or odd, for that particular problem you require one variable, let it be some n. N is nothing but the number you want to check whether it is even or whether it is odd. So see how did we design the algorithm. Step 1 is start as usual. Step 2, you are reading the number from the user, that is n value will be taken from the user. Let us consider your n value is 6. Now what is the third step? Divide the given number by 2 and get the remainder. So when 6 is divided by 2, you are checking the remainder. For remainder, you have to use the symbol modulus. Modulus is used for remainder. If you write 6 divided by 2, it will give you the quotient value. For example, when 6 is divided by 2, it goes 3 times. 2 3s are 6 and the answer is 0. If you write 6 divided by 2, it gives the answer 3. If you write 6 modulus 2, it gives the answer 0. Now our main concept to check the remainder is, to check whether a number is even or odd is to go for remainder only. So we are going to write whether n modulus 2 is equal to this 0 or not. So if it is equal to 0, we display that particular number is even number, otherwise it is odd, because there is no other option. Either the number will be even or the number will be odd. So here now you can see you are taking a number 6, you are dividing it and you are checking the remainder. See here, after dividing by 2, you are getting the remainder. I divided 6 with 2 and I got the remainder value 0. So if the remainder is equal to 0, yes it is 0, then the number is even. Then display that the number is even. Otherwise automatically the number is odd. For example, if you take number 9, when you divide 9 by 2, it goes 4 times and the remainder is 1. Because it is not equal to 0, obviously it is an odd number. So what is involved in this algorithm is a decision making is involved in this algorithm. Okay, so these are different ways of writing algorithms. Similarly, you can implement for other problems also, other complex problems or simple problems. So you have to start with how many variables are required, how many input variables, output variables, what are the calculations to be done, or what are the decisions to be making. You have to implement them stepwise. Now when you implement stepwise only, the same thing can be implemented in program to get the expected output. Okay, now we are going for the next concept, that is flowchart. So as we discussed that algorithm is a stepwise method to represent any problem so that a programmer can write any program easily. Now, when we are already having an algorithm to represent a problem, why should we go for flowchart? Because flowchart is another representation how to develop a program. So, because see, sometimes algorithm is a theoretical way of representing a problem. Like you write stepwise everything, starting from start up till the end stop, what are the variables to be included, calculations, displaying, reading, everything will be involved in algorithm. See, suppose when the algorithm is small, when it is having few number of steps, programmer can easily identify them, understand them and write the program. Let us consider some complex problem is there and the algorithm is too big, so that you are moving from one step to another step, or you are jumping from one step to another step and you are coming back and you are continuing the process. For example, in this particular situations, what happens is it becomes complex, maybe complex for the programmer to understand how to develop the program. So reading theory for such complex problem may be difficult, so understanding it in the form of a diagram may be easy. A simple example, see, whenever you are traveling on road, especially on ghat road or something, so whenever you are moving, whenever you are having a slope, you can see the directions mentioned there. So instead of writing like take a right slope or left slope, so why do we have directions there is because by seeing the image or picture we can easily understand in less amount of time compared to reading some statement or content there. The same thing here also. Wherever you feel like writing algorithm is easy for that problem, you can implement algorithm. And wherever you think that rather than implementing algorithm, if you implement using diagrammatic representation, user can understand easily, the problem can be implemented easily, in that case you can write flowchart. So both of them are having their own advantages. It is not just like we should ignore algorithm. Algorithm can be implemented for simple problems or where the problem completes in less number of steps. For any complex problems, so where you want to show the flow, where the flow goes in different directions. So if you think flowchart is better, we'll go for that. But how to represent this in the form of a diagram? We need to follow some symbols. So first of all, what is the definition of flowchart here? It is a diagrammatic representation, or you can call it as pictorial representation of an algorithm, because you're already having an algorithm that, so instead of going through such complex steps, we are implementing in the form of a diagram. So here flowchart is also useful in developing program only. So we need, but whenever you're drawing these diagrams, you need to remember what are the symbols to be used in the diagram. So we can't use our own symbols there. There are some standard symbols to be implemented. So we have to use those symbols to represent the instructions of algorithm. So flowchart will be better helpful for us for later part, that is writing program or designing a program. So let us see what are the symbols that are to be used for flowchart. So here you can see the symbol and the name of the symbol and the use of that particular symbol. So first symbol is arrow. Arrow represents flow line. So whenever arrow, it is a general thing. So whenever you see arrow, we see the representation of direction, in which direction we need to go. Similarly, here also it represents the flow. So whenever you are representing arrow from one symbol to another symbol, so you can see the flow, that the flow is going in a downward direction. Suppose if I represent an up arrow like this, that means from here it is going backward and it is going to continue. So arrow is a flow line which always represents a direction in which the control is flowing or the program instructions will be continued. Okay. So, and the next one is, you can see an ellipse here, or you can represent it using an oval also. So this is called as terminal. So in your algorithm already we have seen here start and stop. So start and stop have been seen. So to implement that start and stop in the form of a diagram, we need this symbol which is called as terminal. The same symbol is used for both start as well as stop. Okay, and next symbol is a parallelogram which is called as an input or output symbol. So what is input in our flow chart? You want to read something from the user, that is called as input. Reading means you are taking values to process that particular task, and you are displaying something, so display is called as an output thing. Reading is input and displaying is output, because if the compiler displays only, you can see the output on the screen. So for these both things, we can use a symbol that is parallelogram, input and output. Whenever you are reading as well as displaying, you can use these symbols. And see the next symbol, that is called as rectangle, which is used for processing. Processing is whenever you want to initialize some values or whenever you want to represent the formula, in that case you can use this rectangle. For example, in the previous example, we are having addition of two numbers. The formula is sum equal to number 1 plus number 2. Now this particular formula can be represented in a rectangle. So that is the use of the symbol. And next one is rhombus, which is used for decision making, because we have discussed that the problems can be of two types. One is problem solving using some formula, taking some input values, and we are going to get the output. And the next one is a decision making, that is we are going to decide whether it is an even or odd or prime or not or anything, such type of problems. So in that case you can use this decision making symbol. So this decision making symbol you can write here flow in two ways, because when you are making a decision, there is a possibility that either it will be true or it will be false. So you can use one flow of control for true and another flow of control for false. True or false can be represented using yes or no symbols also. And coming to next one, that is connector. A circle is called as connector. This is used to join different flow lines. So whenever your flow chart contains different parts or different paths here, so those paths can be connected through this connector, a symbol, a circle. And next one is off page connector. So whenever you are representing flow chart, and if it is not sufficient, you are going to continue it in the next page, then you will represent this off page connector, telling that the flowchart is continued in the next page. So whenever you are representing the flowchart. And next one is predefined process. So here process is nothing but it contains some statements. A programming language may contain some predefined process, that is predefined, already defined statements, how that function has to work. For example, you are having some printf is there, you can call it as a predefined one, because printf means to print anything on the screen. I am calling it as predefined because it is already defined and the compiler knows it, and you are not going to specify any new definition for that, and you can't change the name of that. It's a predefined thing. For example, I want to calculate square root of a particular number, then I have to use a predefined function like sqrt to calculate square root of that particular number. So these are all called as predefined functions. So whenever you are having some predefined process and you are having some statements related to that, then you can use a symbol for predefined process. Okay, so this represents a group of statements that are performing some processing task. Whatever task is given for that, it is performing the task. That is, we are using it for functions. And next one is annotation. Annotation is nothing but you are giving a comment for that symbol, additional information about the symbol. See, comments. Whenever you write something in a program or in the flowchart also, you can give some comments there. So comments will not be executed, or comments will help other persons or the programmer itself to understand what he has written. For example, if I draw the flowchart using different symbols, I have used different symbols and I have drawn a flowchart, but later maybe I forgot how the process has been went on. So for that reason, what I do is I can write some comments here. So this particular refers to either start or stop, and next one, this particular refers to some I'm taking input variables like PTR. So I can write comments like this so I can better understand. So whenever you are providing comments either for flowchart or a program, it helps for better readability. Either the programmer or any other new person also, when he refers your flowchart or program, he can understand what is actually happening in the program. So program is a different part. How to represent comments in program is a different way of representing. But if it is in the flowchart, this is a way to represent. So we say this symbol is used for additional information about a flowchart symbol, how it is being used and what is the purpose of using it here and what task it is being performed. You can use it for that purpose. So these are different symbols used in flowchart, and we'll see an example for that. So first example is to check whether a number is even or odd. So here you can see that we have already designed an algorithm for this. So the same thing we are implementing here. The first step is start, because start is there and we know that for start the symbol is vowel. So I am going to give it a start, and the next symbol is, or the next instruction in the algorithm is to read the value of n. So you are using a parallelogram to represent this. And can you see the arrow here? This is a flow line. It is telling that after start, the next step is taking input from the user. So it is flowing from one part to another part. This line represents how the flow is going on. And next one, you are taking a new variable num, which is number, and what this new variable is doing, it is dividing this number. N is given by the user. Suppose let us consider n value is given as 8. Now 8 will be divided by 2. I am considering remainder value, so I will take modulus. So I will get some answer. When 8 is divided by 2, obviously the remainder is 0. So what is the number value here? Number value is nothing but this modulus operation answer. Modulus operation answer is 0 because number value is equal to 0, and the condition, see here, you are going to verify. Now here you can see that initially the step is start, which is vowel, telling that you are going to start the process. Next you are taking input from the user, which is a parallelogram. So you can take a parallelogram, and next one is a formula. You are checking the remainder. Here we involve some calculation process. So whatever you are going to check here, you can take it in the form of a rectangle, and you are getting some answer in number, which is nothing but the answer for this modulo operation. So I am getting the value 0 here. I need to check whether it is 0 or not equal to 0. You are making a decision, you are checking, you are verifying. For that reason we will use rhombus, which is a decision box. And if it is equal to 0, then we are having two paths here. One is yes, another one is no, or you can write true or false also. You can use any direction, not a problem. So if it is true, we are printing the number is even and our task is completed. So we are going to stop or end. Suppose if this is false, then we will go towards no and print that the number is odd. Then also we are going to stop the process. So this is how we are going to write a flowchart to check whether a number is even or odd. Similarly, you can draw a flowchart to check whether a number is prime or not, or you can draw a flowchart for any calculation purpose also. Suppose if you are going to draw a flowchart for addition of two numbers, so let us see the method here. If it is for addition of two numbers, so we will start, and according to the algorithm, you can see that we require totally two variables. So I am taking two variables here. You can write in any word format, no problem. I am writing that I am taking two variables. Let it be read the value of number 1 and the value of number 2. I am taking two variables, read. So I use the word read to represent that parallelogram belongs to input. And next, I need to represent the formula for addition of two numbers, that is sum equal to number 1 plus number 2. And where is the answer present? It is present in sum. You want to display again, which symbol we have to use, that is parallelogram. So you can write display the value of sum. Your task is completed. Finally, you can write stop for that. So now this flowchart will be helpful for you to develop the program. Here One more thing, whenever you are checking something or you are verifying something, here you can identify that there is a double equal to. Actually, what number is doing in the previous example, number equal to n modulus 2. We have taken n value as 8. 8 modulus 2 is equal to 0. So, number value is equal to 0. And why aren't we writing if number equal to 0 here, not single equal to? Why did we write double equal to? Is because there is a difference between single equal to and double equal to. If you write a single equal to, it means you are assigning the value. This is called assignment operator, or you are assigning the value. If you write a double equal to, this is called as relational operator. You are checking whether the value is equal or not. For example, if I write a equal to 6 and I will write a double equal to 6. What is the meaning of first statement a equal to 6 here? It means the value 6 will be assigned to a. And if I write a double equal to 6, what does it mean? A may have some value already and I am verifying whether that value is equal to 6 or not. This is verifying, this is checking. This is a conditional thing, but here this is an assignment. So whenever you are checking, you can't use single equal to in programming, you have to use double equal to, and the same thing we write in either algorithm or flowchart also. Okay, so that is the reason if you write number equal to 0, it doesn't mean verifying. It means you are directly giving value 0 to number. But if you want to verify whether that is equal to 0 or not, what is the way of writing an instruction? If number value double equal to 0, when it finds double equal to only, your compiler will start verifying. If you write single equal to instead of double equal to, it will directly give the value 0. So you won't get the expected output, because for all numbers, if 0 is given, it will be always true and all numbers will be printed as even numbers. So this is how algorithms and flowcharts will be helpful for us in developing programs. So that is the session. Hope all of you understood. Thank you.